Hi, good morning, everyone. Ajay is joining. So just wait for 1 more minute and then we will start. So we are going to take the topics of the machine learning, like unsupervised learning, and some more important topics of the how AI can automate the data science, or can it automate or not. So we'll discuss lots of things today. So let's wait for 1 more minute and then we'll start. Hi, Ajay. So I think we can start.
Good
So I
morning.
hope you have access to all the things.
Give me 1 second. Yes, sir, I can share the screen. Yes.
Okay.
Okay. Okay. Hello, everyone. I'm Ajay Sharma from InsideAIML, and today we are going to learn about the unsupervised machine learning algorithm. And in the unsupervised machine learning algorithm, we are going to learn about the BBScan. After learning about the unsupervised learning and supervised learning and a particular algorithm which is BBScan, we are going to learn about will AI automate the data science. It's a hot topic right now. People should know about it because right now most of the people are coming towards the data science and machine learning field. So while hearing that there is something called auto ML, will they kill the auto ML jobs or will they kill the machine learning or data science job? So we are going to discuss that topic also. But at the end, firstly, we are going to learn about the supervised and unsupervised learning or supervised versus unsupervised learning. After that, we are going to learn about the particular unsupervised algorithm that is DBScan. And after that, we are going to give you the answer, will AI automate the jobs or not? So this will be our topic scenarios today. So I hope you will enjoy this. So what is a supervised learning? Supervised learning is means that when you are feeding your machine learning model data plus there is a supervision. Means that this is the machine learning algorithm. I will take an example. Give me 1 second. So this is a machine learning algorithm, suppose ML model. For the ML model, whatever data you are feeding for the training, while training, whatever data you are feeding, that has both the things. That has questions as well as answers. Or in the terminology, I will say that has independent variables and dependent variables. So while training a particular machine learning algorithm, if we talk about question and answers, while training in the supervised machine learning algorithm, it has both questions as well as answers. Independent variables, also dependent variables. What is independent variable and what is dependent variable? Dependent variable is a variable which we are going to predict. An independent variable is by means of predicting this dependent variable. So this is my supervised machine learning algorithm. If I talk about the supervised machine learning algorithm, it is a classification. I will give you an example of classification. What is an example of classification? Suppose I am having three types of animal pictures. I have 1500. Uh, please repeat, sir. Okay. So Vilas, let me tell you one thing here. The thing is in the supervised machine model or supervised machine learning model, whenever we feed the data, we feed it with supervision. Means while training, we feed it with questions and we feed it with answers. Let me give one example to you. A school example I will give you. Suppose we are studying in fifth standard. Example I will take for the fifth standard. From the March, if I talk about the March session, from the March to the December, a training phase takes place, means schooling phase. So I will write it as training. In the training, what we learned questions and about their answers also. Means while teacher is training us, she is showing us the question as well as answer, but this is during the training phase. But in the March, we have the testing. In the testing, what we are given only questions only. And answers we need to generate. Answers we need to generate. So what we are doing here, we are gaining the experience. From March to December, we are gaining the experience. Experience for what? Experience so that in the March month, while going to the testing, I will get only questions only. So therefore, I need to generate or I need to predict the answers. So this is the supervised machine learning algorithm. In that supervised machine learning algorithm, while training, you get questions plus answers for learning, for getting experience and for learning. And for testing, you are getting only questions and answers you have to predict or answers you have to solve. Is it clear now, Vilas? Okay, great. So let's get back. So this was about the machine model. Now let's come across the classification model. The classification means, or here it's known as again three-class classification. Suppose there are 1500 images of dogs, and every image of dog has written it's a dog. It has a label that it's a dog. We have 1500 images of cats, and it has written that it's a cat. And we have 1500 images of person, and it's written for every picture, it's written that it's person. Okay. Now I am feeding all this data to my machine learning algorithm. Okay. Now I am feeding this all data to my supervised machine learning algorithm. Right now, you will tell me, sir, this is a training phase. Are we feeding both questions and answers? Yes, we are feeding both questions and answers. How can I say that? See, I am feeding a dog picture. This is a dog picture. And I am writing also that it's a dog. I am feeding a cat picture. And I am writing also that it is a cat. I am feeding a person picture and I am writing also that it's a person. So while training, I am writing both the things, questions as well as answers. Now my ML algorithm is ready for the prediction. In the prediction, what I am passing an image of a person, but I am not writing it. I am letting my machine learning model to write that it's a person, or I am letting my machine learning model to give me output like this. Did I pass the label? No, I just passed a particular picture. So who is giving me the label? Machine learning model is giving me the label. If I pass the cat picture, cat picture, but I will not pass the label. Label is not given. So here it should give me the answer as cat. It should give me the appropriate label. Suppose now I will pass something which it has not seen in the training. I will pass, suppose, horse. It will tell me that, okay, so let me get it here. So this is my ML. So now if I pass horse here, horse picture. In the training, it has seen only cat, dogs, and person. But in the prediction phase or in the testing phase, if I pass the horse picture, it is going to give me most similar answer. Most similar answer, it is going to write horse picture as dog. Because dog is similar to the horse picture as compared to the person and cat. So whatever you are going to train, whatever you are training your machine learning model, you need to test it based on that data only. You need to test it based on that data only. So this is the classification model. When you classify to a particular quantity, here I am classifying my things into dog, cat, and person. The classification. I hope you understood it. We teach the model with the knowledge it can predict the unknown or future instances. Just we saw. We are teaching our model. See here, we are teaching our model, ML model, with the data. With the data, 1500 dog image with dog written in it, 1500 cat image with cat in it, 1500 image of person with person written in it. But at the end, we are passing only pictures. At the end, we are passing only pictures, and in the pictures, the machine learning model tells me where is the cat, where is the person. In this picture, is it cat or it's a person? In this picture, is it a person or it's a dog? So it's a job of machine learning algorithm. Now, how our data looks like. This is our data. This is the cancer data. In the cancer data, we are predicting whether the cancer is benign or malignant. Benign means non-cancerous. Non-cancerous. And malignant means cancer. So here in this particular data, we are kind of classifying whether a particular tumor is cancerous or it's a non-cancerous. And based on which parameters we are deciding it, we are deciding it in this parameters. We are deciding that in this parameter, that is clump, unif size, unif shape, marginal athesis, single epicenter, bare nucleus, and blend chromosomes, normal nucleus, and MIT. So in these parameters, in these parameters, I am trying to predict whether the cancer is benign or whether the tumor is benign or it's a malignant tumor. So that means this particular thing is dependent on these parameters. This particular class is based on these parameters because in these values, this value is dependent. So therefore, these becomes my independent variable. These become my independent variable. And this became my dependent variable. This became my dependent variable. So for the supervised machine learning algorithm, I will feed both independent variables as well as dependent variables. I will feed both independent variables as well as dependent variables. Means while training, I will feed independent variables as well as dependent variables. But in testing, I will feed only independent variables and predict, and I will predict the dependent variable. So this is all about the data set, how you can handle it. Okay. So this is the label data set, same thing. Okay. See here, it is written here according to this particular thing that this particular value, suppose I am taking the example of this thing, this malignant value is wholly and solely dependent on this means in this value. On these columns, this particular malignant value is dependent on. If we make changes in these values, there are chances that we can make this malignant and benign only. We can make this as benign only by making changes to this particular thing. So therefore, I can say that this is the dependent variable and these are all the independent variables. Same as the thing which I already said. Now we have two types of things: classification problem and regression problem. So in the classification problem, what does it mean? In the classification problem, either the answer will be 0 or either it will be 1, or either it will be one thing, either it will be another thing. Suppose in the classification right now, this is the classification problem, either the output will be benign or either it will be malignant. There is no in between. Either it can be benign or either it can be malignant. Understood? So right now, this is a particular classification algorithm. Now coming to the picture, we are going to learn about the regression. So what is a regression? Regression means this is the classification right now. Classification is the process of predicting discrete class labels or categories. Means here we are predicting the categories or classes. Okay, either we can predict either this is a dog, person, or cat. This is also again a categorical problem. Either we are going to predict whether the cancer is benign or malignant. Either we are going to predict whether the customer will be defaulted or it will not be defaulted. So these kind of things come under the classification problem. Now coming to the regression problem. What is a regression problem? Regression is a process of predicting continuous values. Okay, so here how it does. We have suppose engine size, we have cylinders, and we have fuel consumption, and we have here CO2 emission. CO2 emission, how much a car will produce a CO2? So it is that CO2 emission means that it is dependent on engine size, it is dependent on number of cylinders, it is dependent on number of fuel consumption. How much fuel consumption it takes place. So can I say that these three columns, these are independent variables and this one is dependent variable? Can I say that? Definitely I can say. So what I will do now, I will put a training phase here. I will put a training phase. For a training, I will pass this whole data. For the training, I will pass this whole data. See here, independent variables are present and dependent variables are present. Till here, till the 8th example. So I will pass both independent variable plus dependent variable for the training. I am passing both the things. But now suppose after training my machine learning model completely, what I will try to do, I will try to pass this 9th example in the prediction phase. So in the testing, I will pass this 9th example. In the 9th example, only independent variables are present. So who will generate this dependent variable? ML will generate / predict the dependent variable. I hope it's clear for you. So now the same thing is here. Now we are coming to the unsupervised learning. In the unsupervised learning, all we have is independent variables. All we have is independent variable. There is no dependent variable. So what does it mean? It means that the data has having only the normal data. Means only questions we are having here present, not the answers. We are having only questions present here, not the answer. So what does it mean? It means that whenever I am feeding this whole data, whenever I am feeding this whole data to my machine learning algorithm, I am passing only independent variables because all of them are independent variable only. All of them are independent variable only. All of them are independent variable only. So this becomes my unsupervised machine learning. There is no supervision. Now you will tell me, sir, if we are not teaching our model questions and answers both, so sir, what we are expecting from this model? What we are expecting exactly from this model? We are expecting that this model will find the insights from this data. Insights means, suppose I am a particular person. I'm a particular person. I am going to inside a room. This is a room. Okay. My boss is telling me that in this room, three types of files are present. In this room, three types of files are present. Firstly, private files. Secondly, personal files. Third is private, personal, and third one is public files. Okay, private, personal, and public files. Three type of files are present in this room. So you need to go into this room. The files are in haphazard way, means those are not in order. You need to make an order of those files in this fashion. Means there should be one rack of private files, one rack for personal files, one rack for public files. Same thing we are doing here. We are feeding this whole data to the machine learning, unsupervised machine learning. And we tell unsupervised machine learning how many classes are present there. How many classes of data are present there. Now it's a job of particular machine learning algorithm to assign each data point to which class it will belong. The model works on its own discover of information. It tries to find the insights of the data. All of this is unlabeled data. Unlabeled data means that there is no dependent variable available here. Where we can use the unsupervised learning? We can use the unsupervised learning in the dimensional reduction, in the density estimation, market-based analysis, and clustering. So now how clustering works. Clustering is grouping of data points or objects that are somehow similar by discovering structure, summarization, or anomaly detection. It tries to find the pattern in the data, and based on that pattern, it assigns it to the class. If we look into the picture, the left hand side has been given to the green color. Then based on some analysis, the middle part has been given to the red color. Then the right part has been given to the blue color. Okay. After that, what is the difference between the supervised learning and unsupervised learning? In the supervised learning, we have classification, we have regression, we have has more models than supervised machine learning. and it's a controlled environment. Means we have lot of control over it. Here we try to find patterns from the unlabeled data. Only fewer evaluation methods are available, means only fewer methods are models are available. Less controlled environment. As we are letting model to discover the things, we have less control how it will discover the things. Let's see introduction to clustering. Same data I will take. Suppose this is my data right now. And what I am trying to do, I am trying to pass the clustering in it. I am trying to pass clustering in it. Suppose I am giving this data to my cluster and I am telling my cluster machine learning algorithm that data is having 3 classes. This data, this particular data is having the 3 types of data present in it. The first type of data is affluent and middle-aged. The cluster one is affluent and cluster middle-aged. The second cluster is young, educated, and middle income. The third one is young and low income. I'm telling my machine learning algorithm that these 3 classes are present in this data. Now tell me what are the persons are there who belongs to the cluster 1. How many persons are there who belongs to cluster 2? How many persons are there from this data who belongs to the cluster 3? This is the job of clustering. Now clustering is telling me that the first is belonging to the young and affluent. Sorry, young and low income. The 8th is again belongs to the young and low income. The 4 and 5 belongs to the young and low income. Again, actually this shouldn't be young and low income. This should be young, educated, and middle income. Young, educated, and middle income. Young, educated, and middle income. Okay, and rest of them like 2, 3, 5, 6, 9 belongs to the affluent and middle class. So from this we made a conclusion. Here I will write 1 and 8 are young and low income. Then 7 and 4 are young, educated, and middle income, and rest are young and low income. No, affluent and middle class, middle aged, affluent and middle aged. What we did, we just fed this data. What we did, we just fed this whole data. We just fed this whole data without telling anything. And we gave another information that 3 types of data are present here. Affluent and middle-aged, young, educated, and middle income, and young and low income. This is the information we provided. And this is the data we gave. And this is the output we got. We got which person belongs to the affluent and middle-aged, which person belongs to the young, educated, and middle income, and which person belongs to the young and low income. This is the clustering lines. A group of objects that are similar to other objects in the cluster and dissimilar to other data points in other clusters. This is a clustering method. Okay. How clustering is different from the classification? In the classification, we have both the things. We have both the things, independent variables and dependent variables. Now you will tell me, sir, same is the case here. We are using the same data set. But right now, in the classification, you are predicting a single point, just like in the 10th example. You are predicting a single point. And here, you are predicting all the classes for the 9 examples. You are predicting classes for the 9 examples. And here you are predicting the class for a single example. But here you are predicting the classes for the 9 examples all together at once. This is the difference. You see here, in the classification, you are feeding the history data, which is available, means till 9th example. You are giving that to the machine learning model, ML model, and ML model is predicting one particular thing. But here, in the unsupervised machine learning algorithm, you are giving that to the unsupervised machine learning algorithm, that is k-means right now, and it is giving you the output like this. So in the classification, we are predicting one class, but in the clustering or in the unsupervised machine learning algorithm, we predict the class for each example. I hope this is example clear. Where we are using it? We are using it in retail marketing. We are using it in banking. We are using it in insurance companies. So in the retail and marketing, identifying buying patterns of customers. We can recommend new books or movies to new customers. We can, in the banking, we can use them as a fraud detection in credit card use. Identifying clusters of customers. We can say which customers are loyal to the bank or which customers are not. Means who are paying their loans on time and who are not paying. Insurance, we have fraud detection and we have insurance risk of customers. And we can use them in the publication also, means auto characterization of news. What type of news is it? If I have the 10 newses, suppose I have 10 newses here. News 1, news 2, news 3, news 4, and so on to the news 10. Suppose if I have the 10 newses available here, so in the 10 newses, I can see how many newses are positive and how many newses are negative. This thing I can do. Medicine, characterizing behavior, patient behavior. We can use it in biology, means clustering genetic markers to identify family ties. So these are the applications of the clustering. Why clustering? Clustering means exploratory data analysis. Exploratory data analysis means that whenever we have a data and we need to analyze the data, what type of data it is, what are the insights of this data, that time we are using the clustering. When we need to generate a summary, suppose I have a data set, suppose this is the data set, and I need this data set is having people, person, and their expenditures. Based on the person and their expenditures, I want to make a summary, which one is rich and which one is poor. Which one is rich, which one is poor. I can make the summarization, the persons who are expending more amount of money on luxury rather than basic needs, I can characterize them as rich. People who are not buying anything in the luxury, they are all spending their money on the basic needs, I can characterize them as poor. People who are balancing, sometimes they buy some luxury a little bit, sometimes they are using only basic needs, I can make them average. So this is the summary generation. So I can calculate how many number of people are rich in this particular data, how many people are average, how many people are poor. Outlier detection. Outlier detection means whenever there is something irregular behavior. Suppose right now my credit card expenditure is only 5,000 per month. Example. Suppose suddenly in a 1 month I am expending around 10,000. Tomorrow 20,000, 30,000. So the bank will be suspicious that if this person is having only 5,000 monthly expenditure, why it's suddenly it is expensing so much money. What is the reason? That time what will happen? The bank will block my credit card for this suspicious use, because this is not the way I spend money usually. So they are blocking my, so this is my outlier. finding duplicates if we have duplicates in our data, and pre-processing step. Pre-processing step means whenever we try to clean our data from any problems. So this is why we are using the clustering. In the clustering, we have different algorithms present in us: partition based clustering, hierarchical based clustering, and density based clustering. And the most powerful clustering is density based clustering. And in that, we are going to learn about the BBScan. Okay, so let me share my BBScan PPT. So now we are going to start our DBScan clustering. Okay, we are going to start our DBScan clustering. In the DBScan clustering, what I'm going to write? One second. Okay. See here, we have these two clusters right now. We have two types of data: spherical shape clusters and arbitral shape clusters. If we want to make clusters for this data, it's easy. One cluster, two cluster, three cluster. The non-powerful algorithms, which are less powerful algorithm than the DBScan, suppose k-means. K-means is again an unsupervised machine learning algorithm, or I can say clustering algorithm, but that is not as powerful as DBScan. But k-means can work here. K-means can work here because the clusters are simple. The data segments are simple. But let's come here. If I check how we can make the boundary here, this is the first cluster and this is the second cluster, because we need to separate it. This is the second cluster. In order to cluster your data in this fashion, k-means will not work. Here we need BBScan because the shape is arbitrary. The shape of the clusters is arbitrary. Shape of the clusters is arbitrary. So BBScan will work here. It will work here also, but k-means will not work. Okay, here DBScan also work, but here k-means will not work. DBScan will work. Okay. K-means assign all points to a cluster even if they don't belong to any. According to the k-means, see, this is the k-means application. If we check these 3 points, this point, this point, this point, these 3 points doesn't belong to any cluster. These 3 points doesn't belong to any cluster. But k-means has considered these points in blue cluster and in orange cluster, which is not good. These are the outliers, or I can say unwanted points. But if you see, according to the density based algorithm, it has not assigned these points to anything. It has not assigned these points to anything. It is making this cluster. It is making this cluster. It is making this cluster. So it is not assigning these points to any of the cluster here. It is not assigning these points or these outliers, I will write, to any of the cluster. I hope this is clear. What is DBScan? BBScan is a density-based spatial clustering of application with noise. And it's one of the most common clustering algorithms. It is works based on the density of objects. We are going to see how it will work actually. Okay. Now we have two types of things here, which we need to keep in consideration. First one is radius. The second one is M. M is minimum number of neighbors and R is the radius. This is the R from a particular point to the outside, and the number of elements which comes into this are the neighbors in this circle. Let's take an example. Suppose I am considering this point and my radius is 2. This is my radius. In the radius, I am getting 6 data points. As I have mentioned, M should be 6. If I am getting 6 neighbors in a circle, right now let's calculate 1, 2, 3, 4, 5, 6. If I am getting the 6 neighbors into the circle, then I will consider that point as a core point. So therefore, I put it that as a core point. Now, if you will see me in this particular, for this particular thing, if you will see how many neighbors are there, 1, 2, 3, 4, 5 only, not 6. The criteria is 6. So this yellow point, it's not a core point, it's a normal point. That is known as border point. That is known as border point. Now let's check again. Let's, for this particular point, let's see how many points are coming. 1, 2, 3, 4, 5, 6, 7. 6 are coming and more than 6 are coming. So therefore, this is again a core point more. Again, this is a core point. Then this point, this particular point, let's calculate 1, 2, 3, 4, 5, 6. Again, 6 point. The criteria is 6. So this will again become a core point. Again for this. Okay. So for this particular circle will be there. 1, 2, 3, 4, 5, 6. This will also become a core point. So yellow are border point, red are core point, and now we got a green here. In the gray, we are not seeing not a one single neighbor in it. So this will be a outlier. This will not belong to the any class. This will not belong to any cluster. So this is our outlier. Now we have the core point. Now we have the again core point. We are just taking the example of this point and we are making a radius here. And we are seeing how many elements are coming into this. 1, 2, 3, 4, 5, 6. 6 elements. So therefore it's a core point. Now what we are going to do, the core points which are near to each other, we are going to join them. By that, we are getting the one circle, one cluster. And here, there is no core point near to this particular core point, so therefore it is going to give me this cluster only. It is going to give me this cluster only. So this is how BBScan works. Advantage of BBScan is it is going to use the arbitrary shaped clusters. Means even though if the clusters are not in round shaped, still it is going to make it. See here, the cluster is oval shaped right now. So it is going to make it. It is not going to shy away. Robust outliers, second point, robust outliers means that if the outlier is present here, it will not forcefully throw it to any other cluster. This outlier neither belongs to this cluster, neither it belongs to this cluster. So it keeps it as it is, outside the cluster. Doesn't require specification of number of clusters. Means that I am sending a person inside a room. I am not telling him anything. How many files are there? What type of files are there? I am not telling anything. I am letting him to explore, and he will tell me, sir, there were three types of files available. The first was public, the second was private, and the third was personal. So these were the files available here, and I segmented those. But I didn't told him how many, what are the files present there. I sent him into the room, that's it. Now it's a job of that particular person to see how many types of files are there and to specify them each racks. Okay. This is the advantage of BBScan. So guys, this was all about the unsupervised machine learning, difference between the supervised and unsupervised machine learning, and the BBScan, how the BBScan works. Now coming to our question, will AI automate the data science? Coming to the question, will AI automate the data science or not? So if we see right now that, one second, let me share my PPT. Give me 1 second. Now we are going to learn about will AI automate the data science or not? What does that mean? It means that right now people are doing data science are doing machine learning and data science jobs or deep learning jobs or AI jobs. But right now in the market there is something called auto ML, which is doing all these jobs itself. But will that mean that we are going to lose our jobs? Data science are going to lose our jobs? No. For that, we are going to first learn about what is machine learning. Machine learning is a computer system which adapts and learns based on the data we are feeding. As we have learned in the clustering that whenever we are trying to feed the data, our machine learning model is trying to get the experience and insights from this data. Or we learned in the classification, we are feeding the data as independent variables and dependent variables. And from that independent variables and dependent variables, my model is learning and it is classifying the future objects. Whose class, I don't know. So this is the machine learning for you. It learns and adapts and gets experiences from the data without explicit instructions given. Means I don't need to give explicit instructions. All I need to give is data. There are 7 steps of machine learning: gathering data, preparing the data, choosing the model, training, evaluation, hyperparameter tuning, and prediction. So gathering the data means collecting the data, because machine learning, AI, data science, deep learning, it's all based on the data only. Preparing the data means whatever data we are getting, the data is not in the correct format. The data is not always in the correct values. So we need to correct that. That is known as preparing the data. Choosing the model, as we just saw in the machine learning or unsupervised learning or supervised learning, we have number of models, number of machine learning models are present. We need to choose which one should be best according to the data. For one is training, we need to train that particular model. Evaluation means we need to check the accuracy. If the accuracy is not good, we need to make changes in the hyperparameters. We need to make change in the hyperparameters. So if after making change in the hyperparameters, we need to again train it, we need to again check the accuracy. So it will be like this only. It will be an iterative process. Firstly, it will be training, then evaluation, then hyperparameter tuning, then again training. Till then, we will get the best evaluation, or till then, we will get the best accuracy here. We are going to continuously follow this rule. Train, check accuracy. If accuracy is not good, change the hyperparameters. Go back to training. Go back to evaluation. Go back to hyperparameter training. Then at the end, we are going to use this as for the prediction. Now let's check about the AutoML. AutoML means automated machine learning, which produces machine learning solution tasks for the data scientist without doing unlimited inquiries on data preparation. Means we don't need to do data preparation. We don't need to do model selection. We don't need to do hyperparameter tuning. We don't need to do model compression parameters. All will be done automatically. Will that mean that our job is finished now? We'll see. AutoML can help us in data visualization, model intelligibility, and model deployment. It can be viewed as it can select the algorithm itself, means it can select the machine model itself based on the data. It will change the hyperparameters itself so that we can get best possible accuracy. It can use the iterative modeling, means it continuously use the different hyperparameters so that we can get the best accuracy. It is used in the model evaluation. It's about making machine learning tasks easier to use less code and avoid hyperparameter manual. So what are the packages here? The packages here are AutoML, AutoWake, and AutoKeras. So now there are three main reasons why AutoML cannot replace data science. Give me one. Oh, sorry. One second, guys. I just stop sharing it. So there are three solid reasons why current AutoML can never kill data scientists. Let's see the first reason. The first reason is the AutoML cannot carry out whole data science process. In the data science process, firstly, we have the understanding of business problem, understanding of data. We need to understand the data manually. A machine can never achieve the human intelligence level. It can never understand the data manually. The way a human is accepting, the way the human is achieving the data, or the way the human is achieving the insights of the data, a machine can never reach there. And this is the first and most important step about the machine learning. Sorry, about the data. So the machine will not be able to do this perfectly. So therefore, this is the first thing. This is the first thing. The AutoML cannot carry out whole data science process, because in order to carry out the whole data process, the first thing is understanding the data, which a machine cannot do. The list of data science processes is quite long. We have a long list of data science processes in which a machine learning is just a bullet point. Means that AutoML can be used in the machine learning processes. AutoML can be used in a machine learning processes. But what about the rest of the data science tasks? What about the data wrangling? What about the data manipulation? What about the data acquisition? Those are also the important factors. Those are the factors AutoML will not affect on. AutoML is working on the machine learning only. And machine learning is just a single bullet point in the whole data science process. So therefore, this is the first reason. The second reason is without a data scientist, AutoML cannot work. Means that it doesn't matter how much technological upgrade it will be there. AutoML always needs supervision. And this supervision can vary. It can vary from semi-supervised. It can vary from fully supervised. Means every time we are using the AutoML, we need a supervision there. We need someone who is known as a data scientist to check the result provided by the AutoML. When the data scientist accepts the result then only the results are correct. Or when the data scientist gives the green signal to the AutoML result, then only the AutoML results are correct. Otherwise, closing the eyes and accepting the AutoML results is not in any book. We need to rely on the sides of the data scientist to ensure that what are the results provided by the AutoML? Are those correct results or are those not correct results? If the data scientist telling me the results are correct, then it's correct. If the data scientist telling me the results are incorrect, these are incorrect. I cannot rely on AutoML. I need to rely on the data scientist's insights. So here, this is the second point. The third one is only data scientists can make AutoML a magic wand. Suppose I am not a magician or you are not a magician, but you are having a powerful magical wand in your hand. You are not a magician, but you are having a powerful magical wand in your hand. So what will happen? Are you able to use it? No. You will use it, but you will not be able to use it perfectly. And you can create some problems also by this. But suppose if you are a good magician, and now in your hand a powerful wand comes, now you can do wonders with that. Same thing is here. If you don't know about the data science, if you are not a data scientist, having an AutoML in your hand will not make any difference. But if you are a data scientist, and you are having AutoML with you, it will always help you in achieving the good accuracy, and it will always help you in accomplishing your purpose. Means that a data scientist and AutoML combination is very good, but only AutoML combination, no, definitely it will not work. So at the end of the point, we are discussing it behind the success of any AutoML. Data scientist owns a huge round of applause. Means for every success of AutoML, behind there is a data scientist who supervised it. There is a scientist behind it who accepted the answers. There is a data scientist who validated the answer or who supervised what data we are feeding to. So this is all about, this is the reason AutoML can never eat the jobs or never kill the jobs for data scientists. I hope you understand today's session. I hope you learned from it. Thank you guys. Thank you so much for joining. And this was all about the supervised learning. What is a supervised learning? This was all about a particular algorithm known as density-based algorithm, that is BBScan algorithm. After that, we learned about why AI will not kill the data scientist job. AI is going to make the data science job easy, but it will not replace the data scientist because the data scientist is the key here. Okay. Okay, guys, thank you so much for joining. I hope you understood and you learned from this. So thank you, guys. I'm stopping the session now. Thank you. Thank you, everyone.